let's talk about ways that we evaluate or characterize data from experiments. One that you're probably all familiar with is the mean or the average of the measurements. And this is consistently used. It's one that we use the most, I would say. And that is calculated by adding up all of our values and dividing by the number of values that we have. You're probably familiar with taking averages. Now, another one that we may want to use, or another type of measurement, is the median. It's similar to the average, and it often gives close to the average results, but this is something that we may want to evaluate. And when we arrange our data in increasing order, so from lowest value to the highest value, we just pick the middle value among them. If the data is odd, that would be a single value. If the number of data points is even, then we would just simply average the two middle points to create the median value. This is often more important when we're looking at economic data or data that is vastly skewed by one value or a few values on either extreme end of the sample. Sometimes the median can provide a better measurement of our data. Now, the range is denoted by this W. That's just simply how spread apart are the data. And that is, you take the largest value, subtract the smallest, that is the range of the values. Sometimes that's useful as well, especially when we are designing an experiment that we need to have our values within a certain range for the experiment to work the best. Standard deviation is also something that you may be familiar with, but here is the formula to calculate it. You may not know the formula, and that is the square root of the sum of the individual value minus the average. Take that, square those, divide by the number of values minus 1, take the square root of this entire thing. If you don't take the square root, you'll end up calculating the sample variance, which is just the square of the standard deviation, but we'll touch on that in a second. The other value that you may wish is the relative standard deviation, and in this case, you just take the standard deviation and divide it by the average. And sometimes this is expressed as a percentage, and in that case you would multiply by 100%. Now, the advantage of standard deviation and what it actually measures is how spread apart are the data. So if we have a nice small cluster of data points, just maybe right in this little small area, then it would have a low standard deviation. But if we had our data points spread far apart, then it would have a high standard deviation. Generally speaking, when we are looking for experimental results, we like to have low standard deviations. That indicates that our data is much more precise. Averages are used in evaluating how accurate our data is, but standard deviation is used to evaluate how precise our data is. The other advantage to standard deviation is that it has the same units as our sample averages. And so sometimes you'll see it expressed as the average plus or minus 1 standard deviation, perhaps 2, depending on what you are going for. And that is a measure of the distribution of the data. The variance is useful because you can simply add up the values to each other. So if I have one variance and I have another variance, I can add those two values together, and that is as simple as it is. If I have them in standard deviation, I have square roots involved, and that is not additive. So that is the advantage there. The disadvantage is that it is not in the same units as our average values are. So those are just some of the ways that we evaluate data. There are more, but this is something that will get us started.